going to solve LeetCode 1, which is called TwoSum. It's a pretty easy question, but it has a very beautiful idea, so we will learn about hash maps within this question. So let's see. Given an array of integers called nums and an integer target, return indices of two numbers such that they add up to target. Okay, you may assume that each input would have exactly one solution, so it will be pretty easy to find a pair that sums up to target, and you may not use the same element twice, so we have to use different indices. You can return the answer in any order. That's cool. Okay, so let's see an example here. We have 2, 7, 11 and 15 as an array, and we have 9 as a target, so we will have to return 2 and 7. The indices of these are 0 and 1 right here. Okay, and in this example we have target 6, and we are just going to return 1 and 2 because the indices of 2 and 4 are 1 and 2. Okay, the question is pretty beautiful, so let's see some constraints. It says that the numbers are in order of 10 to the power 9, and the length of the array might be 10 to the power 5. So only one valid answer exists. Okay, so what can we do? The naive approach, let's talk about the naive approach first. The naive approach would be to traverse array twice, right? So we will start with, let's say that, let me take this example here, and I will change that a little bit because this is a easy example. So let's say this is 11, this is 2, actually this is 2, this is 7, and this is like 19. So I wish I didn't copy this because I changed all of it. So let's say, and our target is still 9. Okay, so when we start from this element here, we will never find an answer, but we will have to traverse all the array, other than this, of course. Then we will look for 19 and we will not find an answer. We will look for 7 and we will find the answer. But it will take O(n) squared time, right? Oh, what's going on? O(n) squared. O(n) squared time is very bad within these constraints because it will take 10 to the power 10 operations, which we cannot afford. So what can we do? We can basically store some of the elements in some hash map, and we can check whenever a new element comes if target minus that element exists. So let me write it out. So iterate through the array once and check if target minus nums I is already seen. If so, then we have our answer. If it is not the case, we will just move on to the next element. So let's start coding. What we are going to use here is called an unordered map, which is basically the same thing as hash map, okay, in other languages. So let's write it out. So we have an unordered map of integer. The key is the number itself, and the value is going to be its index. So let's call this UMP, and we have a vector of numbers, right? So let's iterate on this array. So this will return me the number of elements. So let's see. If the element I'm looking at has a counterpart that sums up to target, then we are done, right? So what we are going to do is we are going to use find function of this map. You can do it in other ways, but I will use it this way. So we are looking for target minus the element at hand, right? Because if this thing is inside the hash map, then we are cool. So this should be within the unordered map. So it should not be equal to the nth iterator of this hash map. So if this is the case, I will just take it out and make the answer. So I will return, not here, sorry, right here, I will return the index at hand, which is going to be I, and basically this thing here. So ump target minus nums I. Okay, so otherwise, if I did not return anything right here, then it means that I haven't found the pair right. So what I'm going to do is I'm going to insert, or I can just insert this way, nums I as I, right? Because the element itself is the key and the value is the index. So this is the thing basically, and I will return an empty vector here. Why do I do that? Because it will give me an error if I do not return anything. It will give me actually a warning. So here we will be done because it says exactly one solution exists. So let us run this for some sample cases and see what goes on here. So we see it works. So we can change this like 19, 30, and 21, and let's say I'm looking for 28. It should return me 1 and let's see, 1 and 4. Let's see. Yeah, it works. 4 and 1, 1 and 4, it doesn't matter because they say you can return the answer in any order. So let's submit. And apparently it works, it's faster than 99%. So what about the time complexity here? Let's talk about time complexity. It's definitely not O(n)². So here, keeping an unordered map, we keep apparently O(n) space at most. And right here, what we are going to do is we are just traversing the array, so it will take O(n) time here. And we are using find function in this if statement, so it's going to take O(1) for each function. And here we are inserting a number into the hash map, so it's going to take O(1) time again. So overall time complexity is apparently O(n), which is linear time, and it's pretty good. Thank you very much for watching.